Hi guys, welcome to the Capstone project of data analysis and data visualization using Python. It's really great to see you making progress to the point where you can apply your knowledge to analyze the real data. The datasets in this project are generated using Pandas data reader, which allows us to read the stock information directly from the internet. In this project, we will focus on exploratory data analysis of stock prices. Although you can read the stock price directly from API, however, for your convenience, the CSV files for each company are provided in the course material for you to use. This project is only for practice of data visualization and data analysis skills. It doesn't provide detailed financial analysis, and no advice can be taken from this analysis. You may find this project challenging, as this will bring lots of new concepts. These concepts are helpful for you to evaluate and critically analyze the data and its different aspects. However, learning takes time and needs lots of practice. You must practice your skills while exploring options to present your findings in most effective ways. Domain knowledge is very important, and it plays significant role while analyzing data and presenting solid conclusions. Whenever you get the data to analyze, try your best to get as much as possible information about the circumstances. This is simple science. To present solid conclusions, domain knowledge plays important role. Regarding this project, we all know that the world's oil market is crazy. It has significant effects on the global economy. Several incidents between 2007 and 2009, including the oil price change from 147 to $32 a barrel, and global financial crisis affected world economy and GDP in 2009. A chain of these incidents caused several leading countries into recession. Let's explore how the stock price varies from 2007 to 2017 for some of the oil companies and banks in Canada. In this project, we will also explore the ups and downs in the stock price of the United States Oil Fund and West Texas Intermediate Light Sweet Crude Oil. The USO, or United States Oil Fund, is an exchange traded fund that attempts to track the price of West Texas Sweet Crude Oil, or WTI. WTI, or West Texas Sweet Crude Oil, is a grade of crude oil used as a benchmark in oil pricing. In this project, you may need to recall your knowledge of multi-level indexing as well. Let's move on and have a quick overview on the tasks he's asking for in this project. So the first thing, he's importing some important libraries for data analysis and data visualization. He's also doing imports for interactive plotting here. Then he's reading dataset individually from the provided CSV files. So RBC, CIBC, and BMO are the banks in Canada. Suncor, Encana, CNQ are the oil companies. USO is the United States Oil Fund, and WTI is West Texas Sweet Crude Oil. So the first thing is asking for, check the head and tail of any data frame, for example C and Q. So you need to call head and tail on C and Q data frame. The next question, he is asking for combined banks RBC, CIBC, BMO, and oil companies, Suncor, Encana, CNQ datasets into a single dataset, BO, where B is for bank and O is for oil, and check the head of the dataset. So the hint is use tickers RBC, CIBC, BMO, Suncor, Encana, and CNQ to add a hierarchical index at the outermost level of the data with the keys option in pd.concat. So you have to use concat function here and recreate this output. So moving forward, get the list of column headers or column names in BO. And the next one he's asking for, give the column names, say entity and stock. So you see you don't have column names in your data frame. He's asking to give the names to the columns entity and stock. Moving forward, he is asking to recheck the head of your data frame. Now you notice that you have entity and stock here. If you move back, you see you don't have entity and stock here. So the next one he's asking for, what is the max and min close price for each bank's stock throughout the time period? I'm sure this should be very simple for you to call max and min function. So the next one he's asking for, recreate the bar plots below for max and min stock price. Who got the bigger hit? So the hint is use subplots and pass n columns equal to 2. So you have to recreate these bar plots. The next one he's asking for, line plot can give the idea on how the stock value changes with time. Plot close value of each stock in your data against time. Recreate the plot below using for loop, and a hint is given as well. So you have to recreate this line plot. Look at the index, you have RBC, CIBC, BMO, Suncor, Encana, and CNQ on this plot. So the next one he's asking for, the above plot is good. However, the visualization can be improved with interactive data plotting. You can select the entity you want to display on the plot. Use cross-section.xs method to plot interactive plot for your data. So you have to create this interactive plot. In this plot, you can turn any entity off and turn it on whenever you want. So moving forward, check the head of the WTI. So you have another data frame WTI. He's asking to check the head of this data frame. The next one, set WTI column from value to oil price per barrel and display the head of the data frame. If you notice you have value here, he's asking to change this value to oil price per barrel. The next one he's asking for, all stock went down between 2008 and 2009. Check the oil price and US oil fund stock. How did they change? The hint is once again subplots. So you have to recreate these plots. One is for oil price per barrel and the second one is for USO stock close. So the next one he's asking for, create a new empty data frame called profit. Calculate profit or return on investment for each entity in your data frame and copy the values in a newly created data frame. If you want to explore more on returns or profit, follow this link. However, the returns or profits are typically defined by this formula. So hint in this case is use pandas built-in pct_change method on close column with for loop. So you have to recreate this data frame. And then he's asking for first row is NaN. Can you explain why? I hope you would be able to answer this question as well. So the next one he's asking for, create a pair plot using seaborn of your returns data frame. So you have created this data frame. He's asking to create the pair plot for this returns data frame. If you notice, you see some trends in this pair plot. So the next one he's asking for, what is the best single day gain and what is the worst single day drop for each company or bank? Hint, he's asking to use IDX_max and IDX_min. If you remember, IDX_max returns index of first occurrence of maximum over requested axis and it excludes NA or null values. whereas idxmin returns the first occurrence of minimum over requested access. So he's asking to use these two methods and get the output which is given here. So moving forward, which stock would you classify as the riskiest over the entire time period? Hint is look at the standard deviation of the returns. The next question he's asking for, which stock do you think was the riskiest for the year 2007 and how this changes for 2016? You need to take a look at the past and current times. For this task, you can use IX or LOC to get the slice of the data for the requested dates. So these are the outputs you need to get in your tasks. The next one he's asking for, let's create few dist plots using Seaborn. The first one is create a dist plot using Seaborn of Encana and CNQ returns in 2008. So you need to recreate these two plots. So the one is for CNQ return and the other is on Encana's return. The next task is asking for, let's analyze the moving averages of these stocks in the year 2008. He's asking to plot the rolling 30-day average against the close price of Encana and CNQ stocks. So the hint is pandas.dataframe.rolling, which provides rolling window calculations. You can follow this link to explore more. However, you need to recreate this plot here. So the next one is, a way to present correlation is to create a heat map. Please create a heat map of the correlation between the stock close prices. So you have to recreate this heat map in this task. The next one he's asking for, plot the interactive heat map. So this one is interactive heat map. So you have to recreate this interactive heat map. Should be very easy for you at this stage. So the next one he's asking for, let's see the cluster map. How the correlations make clusters together for stock close prices. So you have to recreate this cluster map in this task. Moving forward, create a candle plot for Encana stock for 2008. The candle or candlestick plot is a style of financial chart which needs a dataset that contains open, high, low, and close values for each time period we want to display. We have all these columns and we can easily plot the candle plot here. So you have to recreate this interactive candle plot. So the next one he's asking for, technical analysis, use .ta_plot method to create a simple moving averages plot of Encana for the year 2015. Pass in periods 10, 30, and 50. So you need to recreate this interactive plot for simple moving averages and pass in the period 10, 30, and 50. So you have to use the suggested function to get this task done. So moving forward, another one is, there is another common type of data plotting, Bollinger Bands. Bollinger Bands are a type of statistical chart characterizing the price and volatility over time of a financial instrument or commodity, using a formulaic method proposed by John Bollinger in the 1980s. So he's asking for to create a Bollinger Band plot for Encana for the year 2015. So the hint is use .ta_plot method for this purpose. So you have to recreate this plot. So guys, once again, I recommend you try to address all these tasks before you move on to the next lecture, where we are going to solve these tasks together. I hope at this stage, these tasks are very simple for you. See you in the next lecture, where we are going to solve these tasks together. Good luck.